All right, let's evaluate this limit. Okay, so we have limit of a function, okay, with fraction x cubed plus 1 on x plus 1 as x approaches to -1. Okay, so if I plug in -1 here, everything will be undefined. So we need to reduce the expression to its lowest term. All right, now let's observe some expansion here in case we're given x to the power 3 plus y to the power 3. Okay, the same as x plus y times. So we have x squared minus xy plus y squared. All right, so can we write the numerator x cubed plus 1 cube? Yes, on x plus 1. We know 1 cube is the same as 1. So I've done nothing to this. So let's go ahead and then expand this one. So we assume x is x, then y is 1 here. So we have x plus 1. Okay. So we have x squared plus x times 1. Okay. So, sorry, minus x times 1 plus 1 squared, that is 1, on x plus 1. All right, so this one will cancel this. I'll be left with x squared minus x plus 1. So we can go ahead and evaluate the limit here. So we can now plug in the limiting value, that is -1. So we have -1 all squared minus 1 plus 1. All right, so we have 1 plus 1, so plus 1. So the answer is 3. All right, now let's use another method. You can choose to, differentiate the numerator here and put the result down and do same to this. The answer will come. That's another alternative. Okay. All right, let's go ahead and evaluate this limit. So we have x cubed minus 8 on x minus 2. So as x approaches to 2 here. So let's focus on the numerator. Now, when you are given x cubed minus y cubed is the same as x minus y, okay, times you have x squared plus xy plus y squared. So let's observe the numerator. Can we adjust this so that it obeys this? Yes. Now we know 8 can be written as 2 to the power 3 here. Okay, so we have x minus 2. Now what are we seeing? We are seeing x cubed something to the power 3 minus something to the power 3. So we have x minus 2, and we have x squared, okay, plus xy, and then we have 2 squared, okay, on x minus 2. So we can do our cancellation, which will be left with x squared. Now remember, sorry, here this side is 2, not, so it's 2x Y is 2, so 2x. Okay, so we have x squared plus 2x plus 4. Okay, so the limiting value here is 2, so I can go ahead and plug in 2. 4 plus 4 plus 4, so we have 12. All right, that's the answer. All right, so let's consider this limit. Okay, now this one is limit at infinity. Okay, so to evaluate the limit of a given function as x approaches to infinity, we always divide each term in the function by the x with the highest power. Okay, so considering the function here, so the one with the highest power is x squared. Okay, so to evaluate this, we need to divide through all the terms by the highest power here. So I'll get x squared over x squared minus x over x squared plus 1 over x squared on x squared on x squared plus 2 on x squared. Okay, so this one will cancel. So this one will move one of the x's here. So this side will go. So I have 3 minus 1 on x squared plus 1 on x squared on 1 plus 2 on x squared. So limit to infinity, my x here will tend to 0. So I will have 3 minus 1 on 0 squared, 0, 0 squared, 0, 2 on 0 squared, 0. So everything on 0, this side will also go to 0. So my final answer will be 3 on 1. So which is 3. Alright, let's consider this limit to infinity. So alright, let's evaluate this. Okay, now to evaluate limit of a given function as x approaches to infinity, so we divide each term in the function by x with the highest power. So we have x to the power 3 as the highest power here. So I'll divide each term by that. So we have this x cube, x cube, x cube, x cube, x cube. Okay, so this side will go. This side reduce this to 2. So this side will go. So I'll be left with 2 minus 7 on x squared plus 3 on x cube on 1 plus 2 on x cube. So to infinity, x will tend to 0. So we have 2 minus 7 on 0 cube, 0, 3 on 0, 1 plus 2 on 0. So 0, 0, 0. So we have 2 and 1, which is 2. All right, let's evaluate this one. Okay, now you can watch my previous video to get more information about how to evaluate limit to infinity. Okay, so just as we said, we divide each term for limit at infinity. We divide, okay, each term with x with the highest power. So we have xx. So it's straightforward. 3x over x over x plus 7 on x. Okay, so this one will cancel. So we have 3 on 1 plus 7 on x. So to infinity, this one will turn to 0. So I'll plug in 0, 3 on 1 plus 7 on 0. The same as 3 on 1, which is 3. Alright, so if f of x equals to this, so we have three given functions here with their range given, okay? So the first one, we have 4x minus 7, 4x greater than 3. And we have x squared minus 3, where x lies between negative 2 and 3. Then we have the third one, f of x, 2x plus 3, if x is less than minus 2. So 1. So f of x got 4x minus 7 to f of x, x squared minus 3. Then we have f of x, 2x plus 3. Okay, the question is, evaluate the limit of f of x as x approaches to negative 4. So where can negative 4 fall? Okay, so looking at the first one, x is more than 3. So x is greater than 3. So negative 4 doesn't fall here. And the second one too, negative 2 to 3. X lies between negative 2 to 3. So negative 4 is outside the range. But for this, x is less than minus 2. So we have minus 3, minus 4. So negative 4 is in this. Therefore, 2x plus 3, this one is the function. So my function here, so this one will be limit as x approaches negative 4, 2x plus 3. So just plug in the limiting value. Since this one is linear, minus 4 plus 3. So we have minus 8 plus 3, which is minus 5 as the answer. All right. All right, let's evaluate this limits together. Okay, so we are given limits of a function, okay, as x approaches to 2. So we have x to the power 4 minus 16 on x squared minus 4. Once we plug in the limiting value, this one will turn to 0, to undefined. So we need to reduce this expression. But how do we do it? Okay, so let's change the numerator to difference of 2 squares. So we can write x to the power 4 as x squared or squared, because in going back 2 times 2 is 4. So minus, so 4 squared is also 16 minus x squared minus 4. All right, so we can say x squared minus 4, x squared plus 4. So we have x squared minus 4 here. Okay, so what do you see? This one will cancel this. So I'll be left with x squared plus 4. So we can now plug in the limiting value. 2 squared plus 4. So we have 4 plus 4, which is 8 as the answer. All right.